Hello and welcome in section 6. In this section we'll be training our model for speech emotion detection from scratch. To do that we need to first get and prepare audio samples. So let's first have a look at what kind of dataset we can actually use for this task, because we need to have quite a lot of data to actually train our model. And we'll be using a freely available Ryerson audiovisual database of emotional speech and song. This is a dataset that contains quite a lot of audio samples that we can use, where there are actors that represent different emotions. So we have emotions like neutral, calm, happy, sad, angry, fearful, disgust, and surprised. So we have quite a lot of data we can work with. But before we can actually use this data to train our neural network, we need to first encode it in a way that it will be meaningful for our network. Let's now go to the source directory, and inside this source directory we have data folder. And inside this data folder, in audio speech actors, this is the dataset that I've just described, and there's also JSON_features. Let's have a look at this folder as well. So in this folder we have already encoded for each wave sample, we have each particular audio sample encoded as numerical values. So let's have a look at the first file. So as you can see, here we have a bunch of values. Those values represent power spectrum inside our audio samples. And this is what we were using to actually extract. This is what kind of features that we're using to actually model the emotions inside the audio samples. And we are using a MEL frequency capstone coefficients. This is simply short-term, the measure of short-term power spectrum of sound. If this sounds a little bit complex, don't worry about it. It simply means that we extracting a certain characteristics from each audio file that represents motion, or the frequency of emotion, you can say that. And those JSON files, each audio sample is encoded that way. And we won't go in through the process of encoding that. Inside the source directory, there's a Python script called wave, or WAV, to JSON.py, and you can have a look at it of how we're actually going about it. It's not a very complex process because we are just using an audio library called Clip to process those wave files and extract those features and then encode them as JSON files. So one more thing to keep in mind about those files is that not only we have those specific features that we can use and train our neural network with. First value inside this array, this is the encoded emotion. This is the exact same encoding that we've seen in the description of our dataset. So this will help us to actually match those emotions to certain features. So the next step is that once we've got this data in the right format, this is the format that we can use with our neural network, we can then load them, and then we have to encode it in a way that TensorFlow.js can actually understand that. So let's now open a text editor and go to script.js inside the source directory for this section. Here we have a main function. This is our main entry point. And let's focus now on the data loading activities. And we have basically two methods that we are using to load the data. So the first thing that we are doing to actually load the data, so now we are at this stage that we have those JSON files. We need to prepare them for training with TensorFlow.js with our model. So we are using data object to do that. After we've created this new object, we can use two methods: get train data and get test data to get our data. So the first question that you might have is that why we do have two datasets. You were talking about just one dataset. So our dataset, we need to split them into two parts. Because the first part, the training part, this is the dataset that we are actually using for training. We also have to have a separate data set that will be used that our model won't see during the training, and after we do the training, we'll use our model, or we use the data set on our model to evaluate its performance. The idea behind splitting the data set is that we need to train our model to solve general problems, right? So when you just verifying model only on the data set has already seen, it means that it can remembers it, and we don't want to do that. We want to have this element of intelligence in our model, this magic that our model knows some kind of a pattern, and this is general enough pattern that can be used on a new data set. So this is the idea behind that. So let's look at this data object. Let's look at getTrainData methods. So our data object is right at the beginning of the script.js. So here we are using for training data, and for test data we're using getData method. And here notice that we are using the same method for both datasets, and the only difference is that we are pretty much just choosing different parts of the dataset. And you may notice that inside the JSON features directory, our samples were encoded from 1 to some high number, and I don't remember how big is the dataset. And we're basically just choosing the random numbers for certain ranges. And we usually split the dataset into those two piles, testing and training. For training, we are using usually the 80% of the dataset, and for testing 20%. So this is what ratio we are using in this case. So let's now focus on getData. Here we are using basically just randomly selecting those JSON files, and keeping in mind that those JSON files are available with our Python server as just ordinary URLs, right? So we are just randomly getting those files. And why we are actually choosing the random data? Because it turns out that depending on the kind of architecture of the model that you're using in machine learning, this randomness, especially in convolutional networks, help in creating better models. So that's why we are using it. So once we've got this data, the actual amounts for training and testing, then we can move into encoding them into the form that is acceptable by train.js. And this is where data to Tensor comes in, and this is again quite a general function or method in this case. We're basically creating first two arrays, getting all the data that we've got from those JSONs, first just rewriting the values from those features that we've encoded, we've put it into the X array. Then after that, we are creating another array, which is information about the kind of emotion, creating another array, which is about emotion in the first value in each sample, as you remember. And we're basically creating those X and Y. So for each element in X is our encoded audio, and then we have label. What kind of emotion is it? And this is just a numerical value. So we create those pairs. So each element from X, it actually is, there's the equivalent of the label in Y. And once we've done it, we then can create those tensors, special kind of arrays that TensorFlow.js is actually using. You can create those, then we are basically just ready for training. So let's go back to our entry point, to our main function. So here we are basically just getting this data, encode them as tensors, and we are now ready for training.